Hi everyone, in this video I'm going to go over how to determine the number of electron domains. Okay, so pretty much we are going to consider the number of electron domain around the central atom because that's what we are going to determine geometry of. Okay, so let's say that this represents the central atom. Okay, so the central atom will need to bond to another atom as well, right, in the structure. So let's say that this is another one. Okay, so the bond that are between the central atom and the other atom would be represented by this bond right here. Okay, so this electron domain region, right, which is the region between the central atom and another atom, this is going to be one region because it occupies the space between central atom and the what do you call it, the another atom, the terminal atom. Okay, so if you have the second one, okay, so you can also introduce this as well, right? So this would be count as two electron domains because you are counting the region between the bonding electron, right? So there are two of them, right, that is bond to the central atom. If you are looking at three of them, right? So when we are looking at the Vesper theory, you want to make sure that these two regions are further apart. The reason for that is because they repel each other. They don't want to be close to each other. Therefore, you need to put them as further as possible from each other. Okay, as far as possible from each other. So now, if I introduce one more, okay, so if I introduce one more here, the best representation of this would be this structure right here, right, which is what we call trigonal planar. Right, the reason for that is because you want them to again to stay away from each other, right? So if you're looking at the central atom for that, and the electron region for this would be 3, right? Because each of these bonds will count as 3. Now, what about if I make double bond versus single bond? Okay, so if I make double bond, let's say I group these two together, right, as double bond that bond to another atom. Let's say like my fist is another atom. This one would be single bond, right, that is connected to my another fist here. You will see that the double bond still is going to require the same space, right, between the central atom and another atom. So therefore, whenever that you see double bond, you are going to count this as one region. You don't count them separate because they occupy in the same region. Okay, so this double bond right here, this sharing electron occupy in the same region. Okay, so therefore in this case, when you see double bond and single bond, total would be 2 electron domain regions because you count this as 1 and you count another one, 2, add them together would equal to 2. Now, if you introduce triple bond, okay, so same thing. Triple bond is going to be the 6 electron sharing between the outer atom and the central atom. So therefore, in this case, the triple bond still going to share, will occupy the same space, right, between central atom and the outer atom. So in this case, if you have single bond and triple bond, right, you are going to count them as 1 for each. So total of this would be 2, right, because one region come from the double bond between central atom and this fist, and the other region would be the central atom and this fist right here, right? So total would be 2. Okay, so that's how you count the number of electron domains. And also all the lone pairs will count as 1 electron domain as well because lone pair occupy space also.